A small particle of mass m moving inside a heavy, hollow, straight tube. Along the tube axis undergoes elastic collision at its two ends. Okay, the tube has no friction. It's closed at one end by a flat surface, while the other end is fitted with a heavy, movable, flat piston. When the distance of the piston from the closed end is L is equal to L naught, the particle speed is V equal to V naught. The piston is moved inward at a very slow speed, V, so that V is much smaller than dl by L V naught, where dl is the infinitesimal displacement of the piston.
So why are they giving like that, sir? What is the meaning?
Which of the following statements is or are correct? The rate at which the particle strikes the piston is V by L. After each collision, the piston, the particle's speed increases by 2V. The particle's kinetic energy increases by a factor of 4 when the piston is moved inwards from L naught to L naught by 2. And the piston moves inward by dl, the particle's speed increases by 2v dl by, I think this is L. What is the meaning of V? Much less than dl by L V naught. It means L by V naught is much less than dl by V. Now, L by V naught is the time taken for this ball to go from A to B. Time is L by V naught. And that time is much less than the time taken for piston to do dl displacement. This is the time taken by piston to do dl displacement, because someone external is moving the piston with a constant but very low velocity, which is v. So to do a tiny displacement dl, where dl is itself very small, to do this tiny displacement dl, the piston needs a time dl by v. And this particle's velocity is so high that the time taken by particle to go from one end to another, from one end to the another, which means the time taken to go from one end to another is much smaller. So by the time the piston does a displacement of dl, this particle has gone back and forth huge number of times, and in each time its velocity will be slightly changed. And how much is that? Let us calculate. By the way, this piston is very heavy. Let's say this particle is approaching the piston with a velocity v. Let's call it as v particle. And this piston is going in this way with a velocity v. And this velocity of the piston is constant. What is v naught? V naught is the initial particle velocity. Yeah. So what is the velocity of approach? Velocity of the particle plus velocity of the piston. The piston is very heavy, so very heavy things velocity doesn't change. So piston will, after collision, also move with the same velocity v, but the particle will go back with a velocity, new velocity v dash. So what is the velocity of separation? Varun, can you tell me the velocity of separation if the ball's velocity or particle's velocity is v dash and the piston's velocity is v?
V dash minus V.
Correct. So v dash minus v, velocity of separation is equal to the velocity of approach. Velocity of approach is vp plus v. So v dash is equal to vp plus 2v. But anyway, the piston's velocity is very small. Now, what is the meaning of this? In each collision or after each collision, the particle's velocity increases by 2v. Because before collision, velocity was vp, After collision, it is Vp plus 2v. So each collision, the particle gains a velocity 2v. Particle gains velocity 2v. Now, if it keeps gaining 2v, 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 2v velocity, how much is the total kinetic energy increased? So that is what is asked here. Okay. And the particle will keep moving back and forth like that. Now, initially the piston was at a distance of L and it is moving slowly. Let us say that after some time, which is a very long time, it is able to come at a distance of X. This piston is being moved slowly from some external agent with a constant velocity v. Initially, when the piston was here, particle was doing collision, back and forth collision like this. But now the piston has come here, particle will go like this, then come like this, go like this, then come like this, go like this and come like this. Let's say if the particle, if the piston has come here at a distance of x, what is the time between successive collisions? So let's say the particle has got a velocity of v right now. Our velocity of the particle is vp. So right now, if its velocity just after collision is vp, now it will go like this, and then it will come back like this. Going will take x by vp time, coming back will take x by vp time. So total time between the successive collisions is 2x by vp. Now, let's say in dt time, the piston moves by v dt towards left. So what is the change in x? Change in x is minus v dt. Why? Because of the backward motion of the piston with a velocity v, x will reduce. So change in x is negative. So minus of v dt. So how much is this dt time? It is minus dx by v. In this dt time, the piston goes towards left by dx. But as I said, this time is much, much more than this time according to question. Which means in this dt time, in which the piston will go towards left by just dx, the particle has gone back and forth so many times. So how many collisions have happened? So number of collisions in this dt time is equal to this time dt, which is minus dx by v, divided by time for one collision. And time for one collision is 2x by vp, or time between successive collision. And this is very small according to question, and this is very big according to question. Which means by the time the piston goes little bit towards left also, by the time the particle has covered hundreds of back and forth. So number of collisions which has happened is vp by 2x, negative sign.
Excuse me, sir.
Huh.
Sir, can you please explain again how you got 2x by VP?
Yeah, 1 second. Just little bit, I'll just do this. So total velocity gained in this dt time is equal to 2v 2 minus vp by 2xv dx. So total velocity gained is dvp. So we get dvp by vp dx. So let us integrate this. dvp by vp, some 1 second, x was also there. So this x was there in the denominator. Okay, this x is still there. So x will be there here also. So minus dx by x. Integrate. Initially, the velocity of the particle was v naught, then its velocity will become v. Initially, the length was L naught, then it will become L. So ln of v by v naught is equal to minus ln of L by So finally it will become some x. So minus ln of x by L naught. So we get V by V naught is equal to L naught by x. Or should I say V will become L naught V naught by x. I'll explain this thing again, don't worry. I just want to arrive at some answer here first. So let us see this. After each collision, the particles is, so this we already got. Now let's talk about this C option. The particle's kinetic energy increases by a factor of 4 when the piston moves from L0 to L0 by 2. So when the x will become L0 by 2, how much velocity will become? Velocity will become L0. So velocity will become 2v0. So if velocity becomes double means 2v0, from v0 to 2v0, kinetic energy will become 4 times. So kinetic energy, yes, the kinetic energy will become 4 times. So C option is correct. If the piston moves inward by dl, the particle speed increases by, okay, that also we have found out. So particle speed increases by this value. And that is equal to, it is asked in terms of dl or dx by x. So velocity of the particle into dx by x. Velocity of the particle into dx by x. Particle's speed increases by this. So this may be wrong actually. The rate at which the particle strikes the piston is V by L. It's not V by L, it is 2V by L. Because after every 2V by L time, one collision will happen. What is the answer given for this question, by the way?
BC.
BC. Okay, now let's come to the doubt of Akshara. Varun, have you understood this?
Yes.
Akshara, tell me what is the doubt here?
Sir, how did 2x by Vp comes?
Okay, good question. Now let's say piston started from here. And now it has come to this position. And now this piston is at a distance of x. If the piston is at a distance of x, let's say particle is here. Just now it has collided with this piston. So what it has to do? Now it has to go back. And while going back, its velocity is Vp. It will cover a distance of x. Then it will collide with this end. Then it has to go back again. Now when it is going back again, the piston is still almost here only, because the velocity of the piston is so small. Only when it goes forward and then go back, then goes forward and then go back hundreds of times, then only the piston gets little bit of displaced only. That's how small the piston's velocity is. So if right now after one collision, the ball's velocity is Vp, then it has to cover x distance towards left and then go back again the x distance to once again collide with the piston. So it has to go x backward and x go forward with the velocity Vp. So time taken will be 2x by Vp. Are you understanding this? If it has collided just now with the piston right now and its velocity is Vp, how much time is taken to go to this end? Distance by speed. Again, it has to travel the same distance x. How much time taken? Distance divided by speed. So total time to go back again for the collision purpose is x by Vp plus x by Vp. 2x by Vp is the time for another collision to happen.
Yes, sir.
During each collision, it will gain little velocity, and that little velocity is 2v. Now, how many collisions will happen by the time piston gets little bit of displaced? Little bit of displaced dx. Time for the dx displacement is dt. Within this dt time, in which the piston goes little towards left, within this dt time, hundreds of collisions will happen. So the number of collisions will be equal to the time taken for the piston to go towards left divided by time between each collision. So these many collisions. And in each of these collisions, the particle gains a velocity of 2v. So the number of collisions into velocity gained in each collision. This is the total gain in velocity of the particle, and the gain in velocity we can write it as d of vp. D of vp, the change in velocity, the extra velocity. So this extra velocity is this. So from here we will do the integration. But these kind of things need time, and when you are learning the concepts for the first time, doing these kind of questions will be difficult. But when you come in fact, we are starting the revision program for 12th class. So 12th class students are much more matured in dealing with so many topics in physics.